Hello everyone. In this session, we will try to discuss about the fiber reinforced natural ceramers. Ceramers are nothing but the ceramic materials. Even in the ceramic materials also, the best example is with respect to our bone itself. Our bone consists of the calcium carbonate. That too, especially even with respect to the calcium carbonate, is a basic constituent of the bone. In depth, or it may be in a precise way, if you start discussing with respect to the composition of the bone, that it is a calcium phosphate. Either it may be the carbonate or it may be the most of the oxides comes under the category of the ceramers, or indirectly what we can say the ceramics. Bone is a typical form of the skeleton that provides a support and a protection for the vertebrates, that too especially the fishes, or it may be reptiles, or it may be the birds, or it may be the mammals. There is another category, especially in the case in the nature, which is nothing but a non-vertebrates, where the bones is not at all there. The biological material systems is one of the great interest, because of the bone exhibits a specific mechanical properties comparable to those metals. However, the bone is far more complicated than that of the metals, and possesses a remarkable ability of the structural adaptation to the external loading. See, in this case, in the case of the vertebrates, the fishes will have the small bones, and if you take an example of the whale, which is having a very huge bones, and even there the strength and as well as the properties matters. But both the fishes and as well as the whales, both it is living in the sea, or it may be in the ocean only. Both lives, and it depends upon the same environment, which is nothing but the the ocean. But the mechanism and as well as the constituents of the bone, it is varying from fishes to a whale. However, the bone is just like a biological material system, is designed for a specific function, and therefore its mechanical property vary not only from animal to animal, but also from location to another location also. Here in this case, what we are comparing is the two things. One is the bone, the another one is the antler. See, the antler is a part which is outside the body. That too, especially these type of antlers normally, which is used as a defending material once if the enemy is attacking it. There are so many what we can say types of antler is there. The another example for the type of the antler is nothing but the horn. Either it may be the horn or the antler, the principle and as well as the mechanism and as well as the structure, both it will remain same. But even in the case of the bones, in the bones, the composition will also remain same, but the strength matters. If we if we have an example with respect to the bone and as well as the antler is emerging from the bone only, but the bone is not so harder. The antler, or it may be the horn, is totally a harder. The antler, the basic constituent of the bone are the protein known as the collagen, and as well as inorganic material phase, the hydroxyapatite, consists of the primarily a calcium phosphate crystals. The collagen is a tough and as an excellent tensile property, but also a flexible one. Even it is varying from 1% of the stiffness as it's as minimal, and as well as a maximum of 1 megapascal stress and as well as strain, which is nothing but a 10% more, and therefore unsuitable to carry the compressive loads and as well as the bending loads. Therefore, in the earlier on the growth process, the thin platelets and as well as the ceramics are added into the specific holes within the collagen. Thus, even the microstructural and as well as the level of the material under a non-homogeneous hydroxyapatite is twice strong and as well as much stiffer than that of the collagen, and thus the resulting in the composite has a 67% of the inorganic components, and most of the adult bones is in the form of a thin platelets. The complex architecture of the bone is as shown in the schematic figure. The structural unit that corresponds to the cell of the wood is the ostium, and as well as which is a hollow tube, and serves as not only the load bearing component, but also conveys blood. The walls of the Austins are constructed much like a wood cells, with a helical arrangement and a thin fibers of the collagen alternating with the parallel fibers of the hydroxyapatite. The hydroxyapatite is a main constituent of the bone. This is a main constant which is a supporting member and also a skeleton structure for the vertebrates. If you start comparison between the antler and as well as the bone is weaker, the antler is harder, but the fibrous structure in the case of the antler is of more. The fibers are in the effect of the equivalent to the whisker crystals. It is important to note that more recent things in the research community is that the mineral is in the form of a platelets and not in the form of the fibers. The resulting materials is a short column of capable of transmitting the compressive loads effectively to avoid the buckling. However, in the view of the adequate protective covering, the bone has around it, and it is not designed primarily for the toughness. The next part what we are discussing is with respect to the fiber reinforced organic matrix, that too especially for the ceramic matrix composites. It's a ceramic, not the ceramics. The molluscus, even the molluscus is also a ceramic phase only, but here in this case normally it is of the calcium carbonate. The calcium carbonate is also a very hard material, that too same as that of the bone and as well as the antler. These also comes under the category of the ceramic composites. These ceramic phases such as the calcium carbonate is not suitable for the structural material, but it is a highly brittle material which is a part of the molluscus.